Hi, my name is Rob DeFeo, Startup Advocate at AWS. I spend my time mentoring startup CTOs and founders, helping them to build their products. When I work with early stage founders, many conversations are about how to build an MVP. A minimum viable product, or MVP, is a carefully chosen term to describe the first product that you build. This is the product that you use to find product market fit for your startup. Many startups use their MVP to scale their business, later rewriting parts as required. An MVP is a continuously evolving product. It will never be completely ready. This quote provides a good piece of guidance. Launch your product early and gives you an opportunity to iterate quickly based on feedback from early users. Your first users are likely to be early adopters, but your product needs to work. They're using it to solve an important problem. The function of your product should be clear. In this example, going from A to B. But add features in an incremental fashion so users can get benefit with each release. Building your MVP is a process, and having an accompanying development process will act as a way to guide you to deliver incremental value. Think of your process as a series of iterations. The goal of each iteration is to provide a small incremental value. Iterations take the form of a sprint. And each sprint should be about one thing, and aim for delivering a usable release at the end of the sprint. Complete sprints are bursts of work, and the sprint contains everything needed to deliver a feature. Developers work without interruption. If you're not a developer and have an amazing new idea, your job is to keep quiet. Take the time and speak to users, get more data to validate the idea. You can change direction, but only at the beginning of the next sprint, but not before. If you're a developer, your job is to deliver the work that you committed to and push back on everything else. There's no fixed time on sprints, but the shorter the better. 1 week sprints work great. And during the hackathon, you can measure sprints in hours. Fast delivery is motivating and rewarding. Everything you do will seem important, but you need to prioritize. Instinctively, you'll look at the expected benefit of each feature and divide it by the expected development time. This is good, but you won't yet have enough data to measure benefit in a reliable way. Instead, look at the speed to implement and the impact on your users. Plotting this is fast and easy, and it gets you most of the way there. So with speed, does it fit in a single sprint for a single developer? And for impact, do you believe that it will meaningfully change the metric you care about? The bottom right corner is distracting. It's quick and easy to implement, but has little value to your customers. You don't need to do it. These will appear often, and don't be tempted. The top right is obvious. You should only do work that lives here. And the bottom left has big but valuable features that you need to deliver, but you should break them down before doing it. And lastly, the bottom left, avoid it at all costs. This is the undifferentiated corner. Your users won't see and they won't care what happens here. Too often I see startups doing work that falls here. If it's not a core part of the product, then use an existing service or product. For the big and important features that don't fit into a sprint, change the scope of the feature, not the process. Make it minimal. Break it down into smaller tasks. Remove the hard and less important elements. Smaller tasks are easier to prioritize, and reducing the scope of a task removes ambiguity and makes it easier to deliver. Even if the feature is not fully complete, you'll have something users can test and validate if it's needed and how it should be implemented. Deploying features builds momentum, and each sprint should end with a feature that is deployed so users can get feedback. CodeStar creates a continuous delivery toolchain in minutes to manage your software development activities in one single place. The early stages of building a business are unique, and the same is true of technology that you build early on. Here are a few anti-patterns to guide you through building your MVP compared with building enterprise applications. In this graph, each orange dot represents a feature. The bigger the dot, the longer it takes to build. Too often, startups are building features needed too far in the future, and this doesn't work. You're moving so fast now in different directions that the future you're planning for is not proven to materialize. Future planned work is usually bigger, so a disproportionate amount of your effort will take time, if ever, to return value. Remove the undifferentiated work. Postpone work that's needed for the future and focus on delivering features that your users are asking for now. These will be faster to deliver, and it will make it more likely that you find what your users are asking for. Doing this, you will most likely lead to accruing technical debt. And this is the buildup of deficiencies in the internal quality that make it harder to modify and extend your product. Technical debt is hard to avoid, especially when moving fast. It's true that getting everything right now will reduce work and make it easier to improve and maintain in the future, but it's hard to avoid technical debt if you're focusing on quickly delivering features. Treat technical debt in your MVP as a cost of moving quickly. While the absolute cost to remove technical debt now is lower, in relative terms, it could be a whole entire engineering team working on this and not features. When you know you're going to need to eventually handle more than one type of thing, consider generalizing. Take, for example, integrating payment systems. Building for one is easy, but integrating with any system, even those you're not unaware of, is really hard. So generalize, but just barely. Make your system capable of handling two kinds of things. This will help you to avoid too tightly coupling. As long as the systems that you are generalizing are not too similar, you'll be abstracting a good amount of flexibility for the effort involved. Building is fun, but maintaining is not. It might seem easy to build something initially, but this approach does not scale well. Everything you build will need to be maintained. If this is not a core part of your product, then don't build it. You're risking not delivering the product that your users really care about. You will build great technology, but at this stage it's best to learn before optimizing. Experiment often and liberally. Use templates or online examples to try services, products, and new technologies. The more that you explore the space, the better idea you'll have of what works and what doesn't. And know when to prototype. A distinction between a prototype and an MVP is that a prototype is an experiment to prove one thing. It's better to prototype outside of your MVP. It's quicker, and if it doesn't work, it won't break your product. There are many different ways to build using AWS, and there are virtually no limits on how services can be combined. This sample architecture covers many of the use cases we see when people are building their MVP. They can be used as a guide to start and then expand as your product develops. Starting with a monolith is often the right choice. It allows for fast development at the early stage, as you don't need to design the process boundaries ahead of time. A well-designed monolith can be scaled horizontally and broken apart later if needed. Depending on the type of product, you may never outgrow the scaling capacity of a well-designed monolith. Lightsail makes it easier to deploy websites like WordPress, Magento, or Joomla, and web applications with pre-configured development stacks like LAMP, Nginx, and Node.js. With Lightsail, you can get online quickly and simply. Elastic Beanstalk is an easy-to-use service for deploying and scaling web applications and services developed in Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker. You can upload your code, and Elastic Beanstalk automatically handles the deployment, capacity provisioning, load balancing, auto-scaling, and application health monitoring. Microservices make it easier to build and scale large applications. Each service is tasked with doing one thing and doing it well. Each service is designed for a specific use case. It has the most relevant data model and infrastructure to support it, making it easier to scale individual services independently. Although each service does one thing, as a whole they combine to provide a full suite of functionality to users. In a well-designed microservices architecture, If any individual microservice is not working, then other parts of the application will still function. Serverless is an easy way to build microservices. In this example architecture for an API, you can see how microservices is built with different AWS services. Initially, your API receives a request from your customer system. API Gateway routes the traffic to Lambda. Next, you build a web client and extend easily by adding authentication with Cognito and storing pre-processed data in S3. Later, you add a mobile client and deploy containers with Fargate, further extended by having API Gateway route to any AWS service. Amplify Framework is a set of developer tools for building, testing, deploying, and hosting the entire application, front end and back. In this example, you can build a mobile application and a web front end using React Native. The website hosted on S3 and CloudFront, and AppSync presents a managed GraphQL endpoint for your clients. You can use Aurora or DynamoDB to store and retrieve data. Next, it can be extended by adding authentication with Cognito and additional data sources such as Elasticache. Integration with Lambda allows for connecting to any external data resource. Amplify Console can deploy static web or single-page applications. It supports frameworks like React, Angular, Vue.js, or static site generators like Gatsby, Hugo, and Jekyll. To deploy, it's very simple. You use 3 easy steps. Connect your Git repository, configure the build settings, and deploy your application. Some decisions that you make now will stick around for a long time or have an outsized importance. These typically are decisions around security and data. So invest the time up front now. Your customers expect that your application is secure and the data they share with you is kept private. With the AWS Cloud, you can be as secure as the most security-sensitive organizations in the world by taking advantage of the many security controls and services available. For web applications, Cognito, Certificate Manager, and CloudFront give secure user authentication, SSL certificates, and DDoS protection. IAM enables you to manage access to AWS resources securely using multi-factor authentication for additional protection. Parameter Stores securely stores your application secrets. And Shield is a managed DDoS protection service that safeguards applications running in AWS. Session Manager allows secure session access to EC2 instances. When working with enterprises or regulated industries, use services such as CloudTrail, and this enables governance, compliance, and operational auditing and risk auditing of your AWS account. The KMS service, Key Management Service, makes it easier for you to create and manage keys and control the use of encryption across a wide range of AWS services. Organizations helps you to centrally manage billing, control access, compliance, and security, and share the resources across your AWS accounts. Decisions about data models and stores last longer than expected. The extra time you put in to this pays off now. First, think about your data model and how the entities relate to each other, and how this data will be read and used in the future. Then consider the access patterns, the read-write ratio, durability, security, cost, and availability requirements. With this information, this table will help you make this important choice. If you're building a monolith or familiar with relational databases, then the relational database service, or Aurora, is suitable for a large number of applications, and it can scale further by using Elasticache. Microservices should look at an independent data store for each service. The narrow characteristics and probably scaling requirements make key value or document stores like DynamoDB or DocumentDB a good fit. For more specialized use cases, look at Neptune for graph databases, TimeStream for time series data, or Quantum Ledger database for an immutable ledger. To gain more confidence and hands-on experience with AWS, access the digital training built by AWS experts, attend our instructor-led classes, and validate your technical expertise with practice exams. And thank you and enjoy building on AWS.